last semester's question. This is 2021 January 2001 examinations. These are questions from last semester. So this particular question was the one should I say our seniors? Yeah, our seniors treated last semester. Okay. So here, the very first question is asking us the very first question is asking us to describe polymorphism and identify its major types. When we look at the word polymorphism on its own, poly means plenty, while morphism means morph means actually shape, like something shaping up to give out something. So when we talk about polymorphism in programming, it is the ability of a particular function to do different things based on the object that it is acting upon. So polymorphism, the concept of polymorphism is actually useful when we are overloading, doing operator function overloading. I think we might probably still get to that particular aspect today. So polymorphism is the capability of an action or method to do different things based on the object that it is acting upon. So you can have a single function with the same name but doing different things. Now there are two types of polymorphism. We have overloading and overriding polymorphism. So this question is a 5-mark question, and it's asking us to give a brief description and also identify its major types.
Hello. Please, can you explain that polymorphism again?
All right, so I will do that. So polymorphism, I said it is like from the word poly means plenty, while morph is shape. So it is something that is having different shapes or different structure. So polymorphism in the programming paradigm is the ability of a particular action or method or function, as you may want to call it, to do different things based on the particular object that it is acting upon. So polymorphism, you can have a single function that is doing different things. So that's the concept of polymorphism. In the Java programming language, which happens to be like the basic, the basic programming language used in almost all of the course materials that we are actually registering for this semester. When we look at a particular method, as it is called, you can have a method that works on an integer with the same name, and you can have that same method working on a string at a particular time with the same name. So in that instance, you have a method with the same name but doing different things. So there is a particular example listed here in our course material that I quickly want to bring out. Just a moment. Oh, it's actually not written clearly, but I'll still try and bring it out. Alright, I don't know how big this is on our screen, but this is the example that was referenced. Let me see if I can make this bigger. Oh, no, I can't. Okay. I don't know if this is bigger on your screen now, like this whole person name reference, part-time employee and everything, so that I can just use this one to like use it to explain another concept of polymorphism, like a method that is having different with the same name but different what's it called. Now we have the line 1 here. We have the person name that is called name and another one called name ref. So the two What I would like, I cannot use this magnify with this. I will have to like remove this magnification. Sorry. All right. So this person here is a class. Please mark. Okay, yeah, this person here that I marked yellow is a class. So it was defined as a class, which happens to be an object. So that object name is a variable. Reference is also name. Reference is also a variable. This one is a variable. Name reference is also another variable. Now with these two variables, they are supposed to be of the class person, which means it's supposed to be a reference to object person. Now, if you look at this line 2, part-time employee 2, part-time employee here is another object which is from the class. Sorry. The part-time employee is from the class part-time employee, which is another object. And employee reference are supposed to be variables that are making reference to that particular object. Now, name here is the instance. Oh, Jesus, sorry. Name here is the instance of a new person, which, like I highlighted earlier, it is actually a person object. It takes in some parameters in the constructor. And now employee itself is also another new part-time employee. But you can see that employee takes in one, employee takes in Johnson, it takes in some float numbers and some integers. Now, the beautiful thing here is that it is possible to, with polymorphism, it is possible to say your name reference is equal to your employee, which means you don't have to specifically define what's it called? You don't have to specifically define employee reference with a new name or new integer, but it's taking the form of the employee declared here on this line 4. So now when you are assigning it like that, it's that statement is like you are pointing it to the what's it called, the name reference object. Now when you point it in such a manner, the name reference becomes your what's it called, the employee becomes your name reference. So in that particular instance, your employee is taking on the shape and form of your name reference. So polymorphism, more than general terms, is a particular object, a particular function, a particular method that is capable of doing many things, even though it is declared as one thing. So you can have a function that is probably the name of your function is to print something. Probably the name of your function is welcome. So now your function can take in an object. You can declare another function that takes in a string. You can declare another function that takes in an integer. So now all of them having the same name but making reference to different object types. One is making reference to a string, one is to an integer, one is to an object. But making reference to different objects is the whole point of polymorphism. So it is an object that is taking on different. It has the capability, it has the capacity to act, to do many things. So I don't know if it is clear, or I should still find a way of explaining it and breaking it down.
So to get this straight, polymorphism is the capability of of a particular method to do many things on an object that's acting upon. That's the
Exactly,
concept.
sir. Yes, sir. So it's still on the same interface.
So the
still in the
instance
same
you now
class.
give, the instance you now gave us a class accepting more than one data type.
Yes, sir.
Okay, I'll put that in mind.
So it is one way or the other related to inheritance, but at the same time inheritance should not be confused with polymorphism. When we are talking about polymorphism, it's still the same thing, but it has different forms. It can do different things. So it is not just doing a single thing. It is not just limited to doing a single thing that is defined to be. Okay, yeah. I think I just saw something that I would like to just show. Let me see if I can find a means of bringing this out. Okay. I don't know if everybody can see this particular image very well. So here we have a class.
If you zoom in properly, you can try.
Alright, let me just bring my okay. Let me bring the magnifier. Maybe it's going to be. Alright, I don't know if it's better now. So here we have a class that is supposed to be class test. So this class has some functions that is capable of doing. So the very first function is called fun, and another function is called fun, and another function is called fun. This void is like this is probably we still get to talk about the syntax of a function. Now void here is what the function is expected to return. Void means it's not going to return anything. So now this fun is the name of the function, or should I say the name of the method, because functions inside a class are referred to as method. Now this int a is telling us that this particular function requires a parameter or an argument that is supposed to be passed inside that function, which is a variable a, and it is supposed to be an integer. Now if you look at this thing, the very first declaration was called fun, but it is only accepting one variable a. The second one is called fun, but it's also accepting, but it's just accepting integer a and integer b. While the last one, which is the last fun, is accepting a character, which is like a string character, which is also a. Now the difference between these three is just the argument and the parameters that are passed inside that function. It is still the same function fun, but it has different forms. It has different. It is capable of doing different things. It is capable of accepting one parameter a as an integer and performing some operation with it. It's also capable of accepting two different parameters which are integers and doing different things with it. And it's also capable of accepting a particular character string and doing something with it. So it's still having the same name, it's still the same function, but it has the capability of doing different things. So that is polymorphism. Alright, so any further question before we take a look at the next question?
So in your own way, define polymorphism.
Sir? Mr. John Bosco, can you
Define
come again, sir?
polymorphism in your own way.
Oh, in my own
Yeah, I said
word.
you should define polymorphism. Yeah.
That's actually what I did though at first. I said in my own word and from my own knowledge, poly means something that is plenty. And when we talk about morph, it's something that has to do with a form or a shape or a surface. So so polymorphism is actually something that has different form and can do different things. So that's like how I would put polymorphism in my own word. So I believe you are satisfied, sir.
Yeah, you can go ahead.
All right, thank you very much, sir. Identify the examples of message passing styles. Message passing. Okay. If I understand what this particular question is trying to ask us here, when we are talking about message passing, it's actually some sort of inter-process communication, like a particular sender communicating with a particular receiver. So I will quickly look up message passing styles inside but I know that it's supposed to be like a sender calling to a receiver, and you have a message. Okay, message passing in computer science is a form of communication used in parallel computing object-oriented programming, and inter-process communication. So, and the message passing systems have been called shared nothing system because the message passing abstraction hides underlying state changes that will be used in the implementation of sending message. Anyways, a brief summary is that the message passing style, message passing style. Message passing on its own is just, like I said earlier, a form of communication between two or more parties. We have the sender, we have the receiver or receivers in case there are more than one receiver, and there might be a possibility of having more than one sender to more than one receiver as well. So here they're asking us about message passing styles. There are 5 different message passing styles listed in the course material. We have the actor model implementation, amorphous computing, anti-object flow-based programming, and SOAP protocol. I think I can say a little bit about that SOAP protocol. SOAP protocol is a sort of a web service in which the full meaning of SOAP on its own is called Simple Object Access Control. It's a messaging protocol. It has to do with communicating with different sockets, and you have your response almost immediately. So you have the sender sending out a message, and the receiver accepting your message and acting on it and sending out a result back that, okay, your message, this is what I'm telling you back in response to your message. So that's just like a basic analogy of how the SOAP protocol works. So I cannot really say much about actor model implementation, amorphous computing, anti-object, and flow-based programming though. So, but these are the 5 types of message passing styles. We have the actor model implementation, we have the amorphous computing, we have anti-object, we have flow-based programming, and we have the SOAP protocol. So it writes the syntaxes for importing individual classes and all classes in a package respectively. Under normal circumstances, this is where I'm supposed to open my code editor and say that this is how you import import stuffs in Java. But let me just quickly see if I can use an online IDE. Okay, so this one is an online compiler. Okay, our compiler is still loading and coming up. Come up depending on it's an online ID depending on the strength of my internet connection. Let me just quickly give a brief summary on the theoretical aspect of the import keyword in okay, let me say in Java, because I think that should be according to the question in Java. Oh, not specifically in Java, but the how you use the import statement in programming. So when you are importing something, there are actually I know I've been making mention of classes and classes all this while. So there is something called a custom class and a system class. I don't know if I should call it a system class, but a custom class is a class that you define by yourself. You write this class by yourself. You give it its constructor, you give it its private and static and final keywords where necessary to define your variables and your your fields, and you set your methods by yourself. Now for system classes, these are classes that are kind of inbuilt. They are not classes that you write by yourself. An example of that is the date time class, the calendar class. You know, when you want to work with a different date and times and time zones, you can just import this one directly from your programming your system, and you don't have to like write it manually. Although you can build a different class, a custom class on an already existing class. So okay, I think our compiler should be on by now. Yeah. So this is actually like a rough the prototype of I will not really call it a prototype. It is what's this? What's the word for this thing again? It's some sort of template. Let me put it like that. Some sort of template for a basic Java program. So this what this one does is to print out hello world. So I'm just going to comment this one out, okay, to show you how you import what's it called. So you actually do importation with the import keyword. So which is supposed to be at the very top of your is the import keyword. Now this import keyword, the way it works is when you are importing something, you are going to specify the what's it called, the package name that you are importing. Take for example, like I mentioned earlier, the calendar or date. Let me see the calendar class in Java. So when you are working with that calendar class, you import it. That's the calendar. The package name is from the utils utility classes. So it's like a subclass in that utility class. So you can just from your utils you import your calendar. Now there is some sort of I've forgotten the terminology again. But whenever you are using asterisks, you are kind of importing everything, like all forms of methods and subclass and everything inside that particular class. Now another thing you can do is to like specify the specific class or method that you need. So when you are specifying that, when you use something they call the dot notation. The dot notation is what you can use to specifically. Hold on, I'll just try to specifically request for a particular class. So let's say I want to bring in my my calendar class. I can just go back to my compiler once again. Hold on, I think someone is. So yeah, we are going to do something like java.util dot calendar, and like I said, you use the dot notation. So inside your Java package, you are looking at a package, the utilities package. You are picking out the calendar class. Oh, that's not the spelling of calendar. That should be calendar. Then we end our what's it called? Our line of code, our block of code with a semicolon. So inside this our hello world class, which happens to be where we are defining our main, which is the starting point of this particular program. One thing I can now do is to make reference of that calendar class that we just that we just imported. So this particular import statement is bringing in this what's it called? This old calendar. So I can just come here and do something like let's say calendar. Okay, let's say private should I say private calendar. Let me see, calendar is equal to the calendar we imported dot get instance. I'm not even sure if this code is going to work, but let's give it a try. Then we can just get something out by saying system dot out dot print line by saying calendar, actually my calendar dot get time. Is that one correct? That should be a method. Okay. Okay. I don't know if this code is going to work, but I'm still going to run it nevertheless, so that we see execute. Probably run into some errors, I don't know. Alright, this one is taking time to load. While this one is still loading, I'll just use time to use the opportunity to explain what this particular line of code is supposed to do. Now, this particular line of code is supposed to take this our calendar class that is imported in this first line, which is what we are referencing here as a okay. This one is going to be the objects that we are referencing. So these are variable that we are creating. It's a field that we are defining. So let me quickly accept. Oh, sorry. So here we are saying this calendar, this is the object that we are making reference to, which means this particular variable is a type of calendar object. So now here we are saying calendar.getInstance. This particular calendar now is not making reference to this one that is at the front here. It's making reference to the one that we imported above here. So and calendar.getInstance is telling it that okay, this particular getInstance is what we use to start a particular instance of a calendar object in the calendar class. So that's how it works with Java here. Then this system out of print line is just a way of outputting of generating an output. And we are seeing calendar.getTime. It gets the current time and time date and time zone that we are at in the present moment and gets that to your screen. And if you see the output here, you have the output as Monday, May 24, 1939, by 10 UTC, then 2021. Yeah. So that's the output from our getTime method. So this particular getTime is actually a method that is inside this calendar class. But because we are creating a variable calendar and saying that this particular variable is a type of calendar object, and we now assigned it to the calendar that we imported, which is the instance of the calendar that we imported, we are now able to use the public methods inside inside the calendar class that we imported inside this our hello world class. So that is how you import your what's it called, you use the import statements in programming. So here in okay, according to the course material, there's something we call predefined classes and user-defined classes. So yes, the user-defined classes was what I was referring to the other time as custom classes. So these are classes that you defined by yourself as a user, while predefined classes are classes that comes with your Java class. So the Java class or Java application programming interface provides you with predefined classes, which can be the building block for constructing new classes. So the import statement, the import declaration is used to identify the predefined classes used in a Java program. So the way you use your import statement is you can say okay, import package name dot class name. So as you can see, we are importing java.util.calendar. Calendar is a class inside the utils packages. The util packages is util package is like a sub package that is found inside the Java class library. So the Java class library is what brings this for us. It is packed with your SDK, the software development kit, when you install your Java programming language. So this is how you make use of the import statement and how you can just you write the syntax for importing individual classes and all classes in a package respectively. So if you are importing all the packages, all the classes, it's going to be package name dot asterisk. The asterisk means everything. So you make use of your asterisk in that particular instance. Alright, so the next question I'll be looking at here now is describe the time data hiding. Okay. Other than data hiding, there is a particular term known as obfuscation. Obfuscation is when you make something obscure or not clear. So it's also sort of like a programming principle of programming, like a sort of a coding practice that you use to keep your code safe, so that when others are looking at it, when third parties are looking at it, it will not be clear to them. But that's not really recommended, because in theory, you are expected to put into practice clear code, like you write a code that is clear, easy to understand, and reusable. But when we talk about data hiding, you can also refer to this as information hiding, which is part of um, benefits that are involved in bundling your code. And when you bundle your code into individual software objects, there are some benefits that are included, which includes the modularity, the information hiding, the code reuse, and the pluggability and debugging. But when it comes down to data hiding, I would like to refer to data hiding or information hiding as encapsulation. Encapsulation is another principle in object-oriented programming. So encapsulation, I like to refer that to the word known as encapsule. When you have something encapsulated, you are putting something inside a capsule, you are closing it up. Let me make use of let me make reference to your tetracycline capsule, your red and yellow capsule. So when you look at that your red and yellow capsule, you see it has a red top with a yellow bottom, and it is sort of like covering something. Now, those constituents of drugs that are inside those red and yellow capsule is not known to you. All you know is that this is a red and yellow capsule. It is used so. When you take that capsule and use it, it does so. But you don't really know the content. Like, it's not as if you are seeing the content of what is inside that your red and yellow capsule. That's encapsulation for you. So data hiding is like a sort of is making some aspect of your objects hidden, so that this set of operations are like operations that happen internally. So, and you can actually sorry for that, there was a little break in the transmission. I don't know if everybody can still hear me.
You're trying.
All right, sir. Thank you very much, sir. So, like I said earlier, the information hiding is a way you actually make it possible for some part of your program to be limited to what you are doing inside a particular object that is not accessible to you.
It's like you've closed your screen, right?
Oh, sorry. That's true. Thank you very much for the observation. I believe the screen should be coming up right about now. Alright, so where am I? Yeah, describing the time data hiding. So this like when you are making part of an object method limited to its internal use only. Take for example, now we have we have this our class here, hello world. This class has a method. This method decides to be public because it's the main method, which is like the starting point of our application. But inside this what's it called, this hello world, I can just do something like private let's say, let me call this an int, say sample int. Now this sample int is supposed to be, it is expected to be a private variable. No, I don't know if we are still going to talk about. Let me just use the opportunity to cover. There are some should I say some keywords that are used to set the visibility of a particular method or variable. One of them is private. We have private, we have public, we have final, we have static, we have I think there are like two others. No, so there are like two other what's it called, keyword. Now the private keyword, the private declaration makes it possible for whatever you are declaring to be limited to the scope of what you are declaring it with. Now if I declare something private inside this public static void main, it will only be accessible to that main function alone. But if I'm declaring a private integer inside out inside this hello world class, this main function is still inside that hello world class, so it will still be able to reference that our hello world class by saying this by using the this keyword. So you can just use this dot sample it, or just call the sample it. It should be able to reference that keyword because it's still within the scope of that class. But assuming I created a separate class and I called it a private variable, it will not be accessible outside the scope of that class. unless I probably say it is public. So then I'll be able to access it outside the scope of this class. So now final it is used to declare constant, like variables I don't want to change. So you can use your final keyword to declare that one. Then statics are like variables that you want to be accessible outside of that class, even without initializing or creating an instance of that particular class as an object. So that's for static. So that's that about digressing into explaining those keywords. So now our information hiding has to do with things that you do within a particular method. Take for example now, we can say, okay, let's create another method here that says private method. Private. Let this one return let it return a string. That's, let's say sample string. So we have it's not accepting anything, but it's just going to return something. So let this one return just a word. So we are returning just a word from this sample string. Okay, let me do it like this. Say we have a private word. Return word. So yeah, let me just, instead of calling this one, instead of giving out, let me just do system dot out dot print line. Then we do what? Oh, sorry. We need our sample string. Let me just do a string my word is equal to sample string. Okay, so then print my word. So hopefully this one will not return an error. Okay, illegal start of an expression. Hold on, let me bring this one outside the scope here. Just say return this dot word. Non-static sample string cannot be referenced from a static context. Okay, so let me just do non-static variable. This cannot be expressed from a static context. Now I'm having some couple of errors that I would like try to explain based on how I understand this is working. Here, we have a non-static word, a non-static variable. This word is not set to be static. Like I said earlier, when something is static, it is not necessary for you to define creating an instance of that word, an instance of that class with your constructor before you're able to use the constructor and the methods that are available inside it. Now, if care is not taken, that can probably be a security lapses. So when there are static components, it has access to all other static variables and static methods. But if a particular variable or method is not static, you cannot expect something so loose as static to come and access it. It is going to be some sort of let me make this one static. Alright, so what I did is to create a word that is set to be static, and I was making reference to that word in a private a private method, which is method sample string. So method sample string, even though it's private and limited to this particular class, I set it to be a static what's it called, which means at the end of the day this one is actually useless. There's no need for it to be it cannot be private once it is static. So you have your static method. That word is not gotten from anywhere inside this method. It is gotten from outside it, which is this one. So at the end of the day, it is returning this one inside this particular line to print it out. So that's why you have just a word listed outside here. You can see that before we actually set this thing to be static, it was having some sort of should I say access issue with accessing something that is static from something that is not static. So information hiding can be a way of saying, okay, whatever you are doing inside this thing, I don't want it to be visible, I don't want it to be accessible to anything that is outside this thing. So that is what information hiding is all about. So I don't know if there's any question before we proceed on to the next question. Okay, the next question says we should identify two categories of a data type. I am not specifically sure the data type that this one is referring to, because we are talking about data types. It can be abstract data types on its own. Hello?
What?
I thought someone wanted to ask a question.
No question. No question at all.
All right. So like I said, I'm not very certain about the data type that they are asking of here. But I know that when we are talking about data types, you can have abstract data types the same way we have abstract classes. And what sort of data types do we have other than abstract data types? Okay, yeah, we have primitive data types too. Primitive data types such as your Boolean, your integers, your strings, your floats. Those are like primitive data types. Then we have abstract data types, and when we are looking at abstract data types, I think those ones are referencing to data types that are like your object, which is like an abstract data type. When we say something is abstract, it's not something concrete. It is referring to a particular concept or idea. So abstract data type, an example of abstract data type, which is ADT, is your object. Object on its own, they are abstract data types. So I don't know, I might actually be wrong about that one, but let me just quickly see if there's anything related to that in there.
Are you there? Hello?
Your string, your byte, your characters, which is your cars, then your floats, your double. Then the non-primitive types, they are your classes that specify a type of object. which are like if abstract data types, because your object are abstract data types, your list they are abstract data types, and a string data type can also be a reference type. Primitive type instance variables of your character, your short, your integer, your long, your float, and your double, they are initialized to zeros. And variables of type Boolean are initialized to false by the default constructor. So they are telling you that when you say okay, let me create a static Boolean value here that we can access. Let's say a static Boolean is said to be truth or false. Truth or false. Now, I'm not saying that this one is equal to anything. So by default, this one will be equal to 0. It will be equal to false. So if I decide to print out truth or false, I should be getting false, because by default it is it is said to be a null value. I think that one is in reference to Java, because according to our material here, they are supposed to be false by default. So, but I think if I initialize this one to be false, then I'll be getting a false. And if I set it to be true, I'll be getting a true. Meanwhile, there's difference between this one and this one. This particular one with string will be interpreted with quotes rather will be interpreted as a string, while this one will be interpreted as false logic. So the difference between these two is just the quote. So quote around anything makes it a string or a character, while you have it when you have your false as a single keyword, you have your what's it called, your truth or false Boolean character. So that's that about data types. So the two types of the two categories of data types are your primitive and non-primitive data types. The non-primitive data types are also called reference data types. So the primitive data types examples are your character, your cast, your int, your float, your double, your boolean, while your reference or non-primitive data types, they are your list, your object, classes that make reference to objects. So that's that about categories of data type. Now the next question is saying that we should differentiate between constructors and methods. When we say constructor, if you have something like public class, sample class, if you have something like this, then let's bring this down and say public, let's say integer private integer a, b, c. Then let's say public sample class, is equal to int a, let's say a param, int b param, and int c param. Now we are going to have, let me setters. So my setters is going to be private set a, private void set a to be collect int a val and say this dot a is equal to a val so let's set b to int b val so then set c to be c val c val. Alright, so our setter is going to be set a to be a param set b then set c param b param. Okay, just a very quick and brief explanation. What this particular one is doing is that this is a new class that we are calling sample class. Now this sample class, it has some private integers which are integer a, integer b and integer c. Now because they are private, they are not accessible outside the scope of that class. So let's say we want to set it, we want to modify it, we want to make some changes, we want to do something, our constructor comes in. This particular method here is our constructor. So the constructor, what it does is it creates an instance and sets those parameters that are served inside of it as a function to be the starting point of the application itself, so that it's not going to be as if we are declaring some private variables which are not accessible outside, which are not modifiable outside, and we still need to make use of it inside of this class. So although there might not necessarily be need for you to be creating the instance of these separate functions like private void set a, private void set b, and private void set c, but when you are dealing with large application and you have to put modularity into consideration, you don't want to carry too much of logic inside your constructor so that your constructor will not be too modular. So what this constructor does is this one is a particular public method, which is a public constructor. It has to have the same name as the class that we are creating. So at DB I call this class sample class CIT. I call this one sample class CIT. I must come and change my constructor to public class CIT, so that it's that okay, before this class can be used as an object, this constructor must be called to set the instance of this particular private variables in memory before we continue to run our application. So the straightforward way to do this would have been to say, we comment this one out by removing it and make sure that it's not working, and say okay, our a is equal to a dot param, a param, our b is equal to b param, our c is equal to c param, and on like that. So it will actually take your a param and set it to the value of your a. So if you now want to make use of this sample class, you can probably come in here and do my sample class CIT is going to be sample class is equal to, so sample class is equal to new sample class CIT, class CIT. Then we now have 1, 2, 3. So now, what this one is going to do is it will create a new object which will be sample class CIT, and it will put in these values which are expected as a constructor, put in 3, put in 2, and put in 1. So by the time this particular object is being created in memory, private integer A becomes 1, private integer B becomes 2, private integer C becomes 3. And the beautiful thing here is you can just create another class, you can create another instance rather, by, let me say, I'm changing this one to a class, and say my new sample class at the same time. Instead of having 1, 2, 3, you can just have 3, 2, let's say 3. Let's just leave it as 3, 5, 3. Yeah. So in this your second in this your second declare in this second instance of a class, which is also making reference to this sample class CIT, you are going to have private integer A as 3, private integer private integer B as 5, and private integer C as 3 as well. So a constructor on its own is created to make it the default function that will be executed upon the creation or the instance of of the object that is set. So it is possible to also have constructors that does not take in a parameter or value, like this particular parameter will probably be empty, and you can decide that, okay, this one is empty, I can decide to set this one to probably 1, set my B to 2, set my C to 3. But at this instance, you know that your private integer in any sense cannot be dynamic. It will always be the same for every instance of that class that you create, because it's not accepted dynamically through the constructor. You cannot really set it during runtime. So that is that about creating parameters without argument. So nothing will be placed in the argument. You just set it to a constant value that you have in your function. So you can import your class anywhere and make use of it. But the main thing that the constructor does is to make sure that this starts as the setting point, as where your program will kickstart from. So when you have a constructor like that, that's where your Java class will start off from. So that's that about making a simple analogy about constructor. Now over to method. I think the question is difference between the constructor and the method, I guess. Oh yeah, differentiating between constructor and a method. So a method on its own, when we say something is a method, like I said, any function that is declared inside a inside a class is called a method. So what your method does can be specific to what your class is supposed to do in the long run. Supposedly you are, let's say, assuming you are creating a class that is supposed to return the population, or let's say return the mean of the average value of a particular score of a class. So you must have you might probably have a function or a method, as it is supposed to be called. You can have a method that is supposed to get the sum of the total score. You can also have another method that is supposed to get you the frequency of those scores, and so you can do your summation f(x) over summation f. So by so doing, it will be very, very easy for you to now say, okay, my class give me the average. So that one might now end up being a public class for you to make use of. Now, the same way your constructors can not have arguments, your your functions to your methods too cannot your methods too might not have arguments. This particular block of code here is a method. This one is also another method. So the way methods are declared, you said you set the return type of the field of data that is in the function, which is the void here. This private is I've forgotten the name they call it, but it's setting the instance of the access to this particular method. If it's a public method, it is accessible outside this class. If it's a private method, it is accessible within this class alone. So now this is going to be a private class. The void there, like I have explained earlier, it is going to set the return type. It's going to tell us that, okay, this function, this method is not expected to return anything. So while the next one after that one is going to be the name of the method. This one is the name of the method, and whatever you have inside your bracket is your argument. And it is also possible for you to set your functions without argument, the same way you can set your constructors without arguments. So differences between what's it called, your function, your methods, and your constructor. Your constructor makes it possible for your object to require the new word whenever you want to make a new instantiation. Take for example, the reason why you are having this new sample class CIT is because what we are actually using this new to call is this constructor that is set here. So that new keyword is making a call to that constructor inside your class. So what your constructor does is that is a special method. It gives you the ability to make use of that new keyword, while your method does not in any way require the new keyword before you can call it. Let's assume we have a public method that is stated here as let's say public. Let's say let me call this one a getter. So if something is a getter, let's say public integer get a. So let's say get a. It has no argument. Then I'm returning this dot a. So what this one will do is that once this is a method that will be executed. It's a public method, which means it can be accessible outside of this class. So which means you can access this method by saying probably you do a class dot get a. So a class dot get a will give you this dot a. So what is your this dot a? This dot a is what you set in your constructor here. So manually we set our a as 1. So that means our a class dot get a is going to return that a value, which is 1 here. So that's a public method, and you can see that we don't have the need to put new in front of this one before we call the get a method. So another difference between the method and the constructor is that the constructor does not require the dot notation to make use of it, while your method requires dot notation. So this means that before you can call your function, it has to be the reference variable dot the method that you want to call. So your your constructor does not require you using dot anywhere. It's not as if you are doing sample class dot our constructor. No, it's not like that. So but it is you are doing your instance of that class dot get a to get the method of that constructor. Well, okay, yeah, another thing, although this one is sort of like similarity, both of them can be overloaded. Overloaded in what sense? You have a particular variable that can have a default value. You probably have what's it called? A single variable that is polymorphic in nature, which means it is of a different what's it called? It is possible to have your constructor here and say it's a but hold on, it's sorry. Inside this our public class, public of sample class, you can have your constructor having int a param, and you also have string a param. No, ordinarily it should cry out that this a param has been declared before now, that why am I calling it again? But overloading and is polymorphic. The polymorphic proper principle of object-oriented programming will make it easy for you to have a single a single method, a single property that is capable of doing different things. So this one is expected to handle integer, while this one is expected to handle a string. So it's going to be on different memory and different memory locations, and there's no way you can have a clash or collision of same name of declaration. So that's one thing that you can do with argument. You can also say, probably say, okay, int a by default, a parameter by default, you are 0. So that means if I'm declaring this function and probably one way or the other I did not put a param, it will by default set 0. And whenever I'm making reference to it in that class, it will be referencing 0. But if I put it in the constructor, like I assign the value in the constructor, it will not, it's going to override the value of the 0 that was set as the default value to the new value. So that's that about overloading. So it's both the constructors and the methods that can do overloading. But another thing that we should also note, you see, when we are setting this our public method here, we use this return keyword. Yeah, but whenever you are using constructor, under no instance, under no condition is your constructor going to make use of that return statement. Your constructor does not have any return type. That's why you see this one having a return type. That's why you have int here. This is a return type. Is int. This is a return type. It's set to void because it's not returning anything. But there's nothing here. It's just the public type, like okay, the access type and the name. It does not have a return type. That's because it does not have a return type. So your constructor does not have any return type, not even void, not anything. But your methods can return void, it can return integer, it can return primitive and non-primitive data, it can return the primitive and the reference data type. So that's something that is worthy of note. So what else is there to talk about the methods and constructors? Alright. A constructor must always have the same name as its class. Yes, like I've said earlier, your sample class CIT must always be the same as the class name. But your method, you can have any name that you want to set it as. But you just have to make sure that it's following the ethics and principles of proper naming standard. So that's that about all I can say about constructors and keyword. Now this question 2 says that you should write a Java class to print the message "I love Java programming." Alright, so here's what I'm going to do.
I love it now.
We've been on this call for 1 hour 15 minutes. That's a very long time. So wherever or whatever we are able to do by 15 minutes time, that's where I'll probably be stopping, so that we'll be calling it a day from here. So yeah, progressing from here, the question says we should write a Java class to print the message "I love Java programming." This is pretty straightforward, and you can probably do it in as many way as you can. I would like to build on this our public class, sample class CIT. So this is what I'm going to do. I'm thinking of clearing out all these methods that I've written earlier. Okay. So let me just say. Okay, let me give it another name. For our Java application, whenever you are writing a class, your class, the syntax of your class must have the access type, the class keyword, and the name of the class, followed by your curly braces. So the syntax is like the access type. I'm not sure if that's the official name for it, but that's what I would like to call it now. You have the access type, you have the class keyword, then you have your class name followed by curly braces. Now your access type, like I've been saying and reiterating over and over again, it can be public, it can be private, it can be static, it can be final. So hold on, let me even check the name for it. I think it should be somewhere in this. cost material. Okay, I'm not getting that one. We'll probably check it out by ourselves later. So it's not properties. Properties are like your variables. Then class specification. A class specifies method reference. So the syntax is public abstract minor. First optional group. Visibility, yes, the scope of accessibility is, can still call it your assessor, is the visibility or the scope of accessibility. So when we are talking about visibility, you can have public, you can have abstract, you can have private, you can have final. So that's the visibility or the scope of accessibility. That's this our access type. So then your class keyword comes in and your class name. Now there are some optional what is it called, optional syntax that you can use to define your player, your class. So those optionals are like extend. We also have implement. So I will try to say a little bit of information about the extend and implement. Extend, it tends to inherit. This is where the concept of inheritance comes in object-oriented program. So if you say your class A extends class B, that means, if you say your class B extends class A, that means class A is like the parent, while class B is now like tapping from class A. So let's assume that you have a super class that is supposed to be okay. There was a particular reference made mention of in the course material. It is about a bicycle, if I get it correctly. So you can have your super class of bicycle saying something about the blueprint of your bicycle, like your gears, your pedals, your wheels, your probably your seats or anything. So yeah, or you can have the blueprint, like the main blueprint. Now if you are now having a specific brand of what's it called, bicycle, you can now say that, okay, this specific brand extends this main class of, like this super class of bicycle, to make use of some public methods and properties of that main of that super class. Now implement. When you are implementing something, implementation has to do with implementing an interface or a specific function that does something. So it means you are implementing a particular function out of a class, and not necessarily making use of the whole class, but making use of some of the class, some of the method inside that class. But they are optional, and it's not all the time that you have to make use of that. It's only when it is necessary for you to make use of it in your program. So using this following syntax, we are going to write our Java program. So say public, what's the class name? Let's make it
Static.
we are not going to assign static to this public class, because number one, it's not as if we are going to make references of it in another package or program. We want to run this particular file and make sure that it works. So the next thing I'm going to add is just the class keyword, then the class name. Let me pick someone's name here. Let's say I can see to be some go some here. Let me make use of that one. So we can have a class like this, and followed by our curly braces. So inside our class, this is where we are going to do our what was it called, printing I love Java programming. There is one thing worthy of note. in a particular Java program from a particular Java class, the entry point of your application is the main function. So the main function has to be public. Setting it to static makes it easy for your compiler to reference it and just run in your program. So here you are going to have your public static and your void because that's the return type, like it's not returning anything. So then the name is main as usual, then followed by the input for the parameter and our curly braces. Then now we are now going to say this particular class should print something. So system dot out dot print ln, then let's put in the string I love Java programming, even though I hate it with passion. There's nothing to love in this big and robust language. Now we are going to have a problem. The problem we are going to have is that this our application is having two entry points. The hello world class is having an entry point main. This one is also having an entry point main. So I'm just going to clear this one out, even with our import statement, and let's run this. Hopefully we should not have any problem. Said main method is not found. Oh yes, our main method is missing the what is it called? The string argument function. Sorry, that was just a quick response to something. So we are supposed to, like, if you look at this, our error here, it said main method is not found because there is something missing. This our main method is supposed to have this one. Now the question is, why am I actually making use of this thing, this particular string args? Let me type it out here before I continue making that string. Sorry, it's a list of strings, so it's going to be string args. So that's it. So the question is, why do I need this particular argument when I'm not even like making use of it in my method, in my main method? Well, like I said earlier, the very first main the starting point of execution for this our program is the main method, and the way we define and declare our main method is supposed to be a public variable which is supposed to be static. Now the thing with it is that the Java virtual machine is reading that one as an indicator for it to be where it's going to start reading and declaring this what's it called, this particular program. Now any form of a command line arguments that I have to call and use to make reference to Java SDK will be passed in through that particular that particular string, that particular args string. So let's do one simple arc to actually see what it contains. I'm going to comment this one out. I'm still going to come back to it. I'm going to use what we call a simple for loop. You do a for loop with your for keyword. There are many ways, more than one, in which you can do a for loop. So I'm just going to do for each of those let's say for each of let's say it should be a string. Each of the components in args should give me then my curly braces. Let me print it out. System dot out dot print line. Then I have my components. So yeah. So let's actually see what is inside this component. inside this ARGS rather. So here, okay, let me put something here. Let me put something here. Plus, this is, let me call this indicator asterisk. Let me execute it. All right. So I'm not having any response other than what's it called? My what's it called? Other than the what's it called? The language the class I'm running. So here I think I'm supposed to have some lines. I don't know why this one is not printing out some lines. String. Okay, what if it's a list of arguments that is like this? Not as if I'm passing out any argument as well, but okay, I'm not having any printing, so it is virtually empty. Well, anyway, it is supposed to be what the Java virtual machine used to execute some command line on the Java commands on the command line. I do believe we are using Java for building specific applications with specific frameworks like Android or probably your Spring framework for web development. There will be no need for you to have any public void main in your program. There will be no need for you to put this string ARGS or anywhere near it. But I think the reason why we have this one here is because we are executing these commands on the command line with the Java SDK. From my own perspective, that's why we have it like that. And I was not expecting it to be empty. Anyways, let me just put our string ARGS here. We can have it as different formats. It can be the ARGS as list here in this format, or a list of string here. So in the same vein, we are still going to, let me print out, I've commented this one out. Execute. So yeah, you can see our result here. I love Java programming. That's the output of our code. This is all that is needed to gain 6 marks, just like like 2, 3, 4 lines. Okay, let's try and have another class here that says, another way that we can probably do this is going to be more lengthy. You can say public class another user to be, let me first of all declare a string. Let's say private string. No, it's going to be static because I'm referencing it inside a static static. Let me make it final so that it is not going to be editable. Static final, and I say this is outputs. Output is equal to, so another user loves programming but not Java programming. So then, alright, so I can now come here to do my public main, public static void main. Then we have a string of arguments that is going to be for us to say system dot out dot println. Then say, instead of us to put that string, they're just going to put output. So yeah, let's try and run that one. We have an error that says identifier expected. Identifier in what sense? Now I failed to put an identifier. I failed to indicate if this variable is going to be a string or an integer or a list of string, or like it's going to be a primitive or non-primitive data type. So one thing that we should also note or notice, like understand about Java programming language is that it is a strictly typed programming language. It is not that you can just declare a variable and expect it to automatically understand that this variable is going to be an integer or a string or a boolean or a float. No, you have to specify. So this one is supposed to be a string, so I'm putting a string here. So I put my string here to tell it that yes, this is supposed to be a string. Let me execute that one. I should not have any error. Okay. Said I have an error here. Another class, another user is public and should be declared in a file named another user. Yeah. When you are running your what's it called? You're writing your codes. This particular class here, there should be only one public class per file. So that is going to be your package name and your file name. So I'm supposed to like write this public class in another file separately. But the way I can probably work around this one is to say private, then execute. Modifier private not allowed. Anyways, let me. Alright, so I think that's that about declaring, creating a Java program that says I love programming or whatever it is you expected to put inside that question. The difference between this particular example and the first one we did is that instead of putting the what's it called, the string inside our inside our print line method, I actually assigned that string to another variable. Then I now printed out that variable. So that's all I did. So I just saved it in a particular memory pocket. Then I make reference to that memory address by calling the variable name to print it out. That's that about writing your Java program. Okay, and my time is fast spent. Still looking at the association property of a class and two advantages of software reusability. Association property, I don't know what that one is talking about, but we are talking about reusability of a code. It is the whole concept behind reusability is using an already existing object. Take for example the way we use calendar in the first example that we did. We are not the one who wrote the calendar class, but we're able to reuse it and make use of it to work with our program, build other programs. So one of the advantage of reusability is that it makes code, it makes software development process faster, because you don't have to reinvent the wheel and start from scratch and write your code from the beginning and everything. I just pick up the class that was written that's already in existence and reuse it in your code. So what else can we say about reusability? Okay, it makes your code faster. It makes your code. It makes I would say it makes your code neat when you are writing it, like readable. But let me just not give you what I'm thinking in my head. Let me consult the material. Usability. Okay. Is a property that makes a class a vital tool in object-oriented programming. So software reusability is it's when you are packaging software, you make it possible for future software systems to reuse that class. So that's where software reusability comes into play. Like I said earlier, you don't have to like restart all over again. You can just use existing classes and objects to building upon that one to invent and bring about new innovations. So two main advantages of software reusability: it saves programmers the time and effort they would have used in reinventing the wheels. Okay, so that one was right on point. So another advantage is that Programmers build more dependable and efficient systems because existing classes have gone through extensive testing and debugging and performance tuning. So you know that our calendar class, there is no way we can write use our calendar class and have error. So you can see the small classes that we've tried to write. Ordinary I love programming, we faced like 2-3 errors, 2-3 bugs before we actually got I love programming. But one good thing about already existing objects and using about software usability is that already existing objects and classes, they've gone through the whole software development process and methodology. They've gone through adequate testing, debugging, and it is actually ready to go. So it's in good performance. It's in its efficiency is top notch. It's not as if you have to start thinking that is it better for me to use a private here or use a static instead? Is it better for me to make this one a list or just make it a simple primitive variable? Is it okay for me to just extend this one or leave it as a single class? So already existing softwares have gone through extensive testing and they do not need to be, just makes your work faster. You don't have to go through the whole process of doing the tuning and everything anymore. So let me look for this association property to see what that one is. Association.
Is it the network that is disturbing?
Anyways, it has been a great experience so far, and I really appreciate the whole lectures and all. Hopefully, the class sessions continues tomorrow. Yeah.
I really wish there would be a recording. I mean, a recording concerning this, pasted in our various the platform so that we can be able to go through because network is terrible. God bless you. I really learned a lot today.